Hello there, and welcome back to Sleepy Albert. I am so very glad you have chosen to join me again tonight. Wherever you are in the world, whatever the hour, I hope you have found a small sanctuary of calm, a quiet moment carved out just for you. Perhaps the moon is casting a silver light through your window, or maybe the afternoon sun is painting long, lazy shadows across your room. Are you nestled in bed, ready to let the day dissolve into dreams? Or are you simply resting your eyes for a while, letting the world outside carry on without you? It is a precious thing, this stillness, and I am honored to share it with you. As we prepare to embark on another gentle voyage, if you find solace in these explorations of the cosmos, a soft tap of the like button is a quiet and wonderful way to let me know. It helps this little channel to keep its lights on, shining for others who might be seeking a moment of peace. Tonight, we are venturing out on the grandest journey imaginable. We are not aiming for a planet, a star, or even a galaxy. We are traveling to the very limit of our perception, to a place that exists more as a question than as a destination. We are going to the edge of the universe, not in a craft of metal and fire, but in the silent vessel of our minds, powered by curiosity and guided by starlight. Our mission is to stand at the precipice of the known and peer into the profound, endless mystery of what lies beyond. It is the oldest and perhaps the deepest question we have ever asked. What is outside of everything? This is not a journey of answers, but one of wonder. We will drift through concepts as vast as space itself, and there is no need to grasp them tightly. Let them wash over you like gentle waves on a distant cosmic shore. Let your breath find its own slow, steady rhythm, like the turning of planets in their orbits. Let the tension in your shoulders and your jaw release, letting go of the day. There is nothing to do now but listen and wonder and drift. And as always, please remember that our time together is for relaxation and imagination. Nothing here is intended as medical advice. I am simply a sleepy scientist, humbled by the scale of the cosmos, and I am so pleased you are here to explore it with me. Let us begin. Our journey starts right here, in this quiet moment. Feel the gentle pull of Earth's gravity, a constant reassuring presence holding you. It is the anchor for our voyage. Now, in your mind's eye, let that pull soften. Let us begin to float upwards, gently, effortlessly. We rise above the roof of your home, above the quiet streets and sleeping landscapes of your town or city. The world unfolds beneath us, a patchwork of light and shadow. We see the curve of the continents, the deep, dark blue of the oceans, the swirling white patterns of clouds. Our planet, our home, becomes a beautiful marble sphere, hanging in the blackness of space. It is a sight of breathtaking fragility and strength, a single vibrant jewel of life in the immense silence. We pause here for a moment, in silent appreciation for this world we have, for now left behind. We turn our attention outward. The sun, our familiar life-giving star, shines brilliantly. But from this vantage point in the vacuum of space, its light does not scatter. It is a sharp, clean brilliance against a backdrop of perfect black, dotted with the steady, untwinkling lights of other stars. We drift past our moon, a silent gray companion, its cratered face a testament to billions of years of cosmic history. Its surface is a landscape of quiet desolation, but it is our desolation, a part of our celestial neighborhood. Our journey takes us further into the solar system. We glide past the rusty ochre glow of Mars, the fourth planet, a world of canyons and polar ice caps, a quiet reminder that other worlds have their own stories, their own ancient pasts. Beyond it, we navigate the asteroid belt, a sparse, vast ring of rock and ice, the rubble left over from the formation of our solar system, each piece on its own silent, lonely orbit around the sun. Then, the giants come into view. Jupiter, immense and majestic, a king among planets, its atmosphere a turbulent canvas of storms, with its great red spot churning like a colossal sleepy eye. Its faint rings and its family of dozens of moons form a miniature solar system of their own. We drift by, feeling a sense of awe at its sheer scale. Further out still, we see Saturn, its famous rings of ice and dust shimmering like a celestial halo. A sight so elegant and perfect, it feels less like a planet and more like a piece of cosmic art. The light of the distant sun catches the trillions of tiny particles, making them glow with a soft, ethereal light. We continue our outward drift past the faint, blue-green orbs of Uranus and Neptune, the ice giants, cold and mysterious in the deep twilight of the outer solar system. And finally, we push beyond the orbit of the last known planet, through the Kuiper Belt, home to icy worlds like Pluto, and onward toward the very edge of the sun's gravitational influence. We are now entering the Oort cloud, a theoretical, immense sphere of trillions of icy comets surrounding our solar system, a vast cold shell marking the final frontier of our home. It is so vast and the objects so far apart that it appears as an empty void, but it is here, in this deep, cold silence, that we truly leave home behind. The sun is now just the brightest star in the sky, its warmth no longer felt, its light just one of many. We are no longer solar travelers. We have become interstellar. Before us now lies the galaxy, our Milky Way. From our new vantage point, we can see its structure. It is a colossal spinning disk of stars, gas, and dust. A great pinwheel of light, some 100,000 light-years across. We can see the luminous central bulge, a dense sphere of older, yellower stars, and at its very heart, a supermassive black hole, a quiet, sleeping giant whose gravity orchestrates the dance of billions of suns. From this bulge, the great spiral arms sweep outwards, glittering with the light of younger, hotter, bluer stars. These arms are laced with dark, intricate lanes of cosmic dust, the raw material from which new stars will be born. Our own sun is located in one of these arms, the Orion arm, about 2/3 of the way out from the center. Let us drift into one of these arms. It is not a solid structure, but a region of higher density, a cosmic traffic jam where stars and gas clouds move more slowly. Here, the universe is alive with creation. We see vast glowing clouds of gas and dust called nebulae. They are stellar nurseries, the birthplaces of stars. We float past the Orion Nebula, a luminous cavern of pink and purple light, where thousands of new stars are igniting, their stellar winds carving out great bubbles and pillars in the surrounding gas. We see the pillars of creation, immense columns of cool hydrogen gas and dust, so large that our entire solar system would be dwarfed by them. Within these pillars, new stars are forming, hidden from view, their warmth slowly pushing back against the cold gas that cocoons them. We pass by clusters of young, brilliant blue stars, burning with fierce intensity. They live fast and die young, seeding the galaxy with the heavier elements forged in their cores. We also see older, calmer stars, like our own sun, and faint, cool, red dwarfs, the most common type of star in the galaxy, which will burn steadily for trillions of years, long after the bright blue giants have faded away. The galaxy is a city of light, full of birth, life, and death, all happening on timescales so immense they are almost beyond our comprehension. Our journey must continue. We now drift out of the plane of the Milky Way, leaving our home galaxy behind. It shrinks as we move away until it is just one of many islands of light in the darkness. We have entered the intergalactic void. The scale of our journey has now expanded almost unimaginably. The space between galaxies is vast and profoundly empty, more so than the space between stars. If our galaxy were a single grain of sand, the next nearest large galaxy, Andromeda, would be another grain of sand a few inches away. We can see it now, another majestic spiral, slightly larger than our own, a sister city of light across the void. The Milky Way and Andromeda are the two largest members of a small cluster of galaxies called the Local Group. They are bound together by gravity and are, in fact, on a slow cosmic dance that will, in about 4.5 billion years, result in a gentle merger, forming a new, larger elliptical galaxy. But the Local Group is just one small neighborhood. As we pull back even further, we see that galaxies are not scattered randomly through space. They are organized in a magnificent, intricate structure known as the cosmic web. Just as stars are gathered into galaxies, galaxies are gathered into clusters and superclusters. These superclusters are linked by long, tenuous filaments of galaxies and dark matter, stretching for hundreds of millions of light years. It is as if the universe is a great dark sponge, and the galaxies are the luminous material of the sponge itself, forming a network of threads and walls that surround vast, nearly empty regions called cosmic voids. Our Local Group is just an outlying resident of the Virgo supercluster, a massive collection of thousands of galaxies. And the Virgo supercluster itself is just one node in an even larger structure called the Laniakea supercluster, a name that means immeasurable heaven in Hawaiian. Our mental voyage now takes us across these voids and along these filaments. We see countless galaxies of all shapes and sizes, spiral galaxies like our own, elliptical galaxies that are huge, round balls of older stars, and irregular galaxies with no defined shape, often the result of galactic collisions. Each point of light is a home to billions or trillions of stars, and with each step of our journey outward, we are also taking a step backward in time. This is perhaps the most crucial concept for our journey to the edge. Light does not travel instantaneously. It has a finite speed, about 300,000 kilometers per second. This speed is incredibly fast. But the distances in the universe are so immense that light takes a very, very long time to travel between objects. The light from our sun takes 8 minutes to reach Earth. The light from the nearest star system, Alpha Centauri, takes over 4 years. When we look at the Andromeda Galaxy, 2.5 million light years away, we are not seeing it as it is today. We are seeing it as it was 2.5 million years ago. We are looking into the past. As we look at galaxies that are billions of light years away, we are seeing the universe as it was billions of years ago. We are cosmic archaeologists, looking at the fossil light from an earlier epoch. The further we look, the younger the universe we see. The galaxies appear different. They are smaller, more ragged and bluer, full of the violent energy of star formation. They are still coming together, still merging and colliding, in a universe that was much smaller and more crowded than it is today. So let us push our journey to its absolute limit. We travel outward, past galaxies so distant their light has traveled for 10 billion years, 12 billion years, 13 billion years. We are now seeing the universe in its infancy. We are looking for the very first galaxies to form, the first pinpricks of light to illuminate the cosmos after the dark ages that followed the Big Bang. And as we look to the very, very edge of what our telescopes can see, we reach a boundary. This boundary is what we call the cosmic light horizon, or the edge of the observable universe. This is not a physical wall. It is not a place where space ends. It is a horizon of time. It is the furthest point from which light has had the time to reach us since the universe began 13.8 billion years ago. Any object that lies beyond this horizon is, for now, invisible to us. Its light has not yet had time to complete the immense journey across expanding space to reach our telescopes. The observable universe is a sphere, with Earth at its very center, and this horizon marks its boundary. Everything we can see, every galaxy, every star, every filament of the cosmic web, is contained within this sphere. It is our cosmic fishbowl. But the universe itself, the ocean in which our fishbowl is floating, is almost certainly much, much larger. We are now standing at the precipice. We have traveled from our quiet room to the edge of all that is known, to the boundary of all that can be seen. We are looking out at the oldest light from the youngest moments of the universe. In every direction we look, we see this boundary, this gentle curtain marking the end of our vision. And the profound question hangs in the silent, cosmic air. What lies on the other side? What is happening just beyond that horizon, in the part of the universe whose light has not yet reached us? It is here that our journey must leave the realm of observation and enter the quiet, wondrous realm of possibility. The ground of solid fact gives way, and we are now ready to drift into the great, open ocean of the unknown. Let your mind be open. Let your curiosity be your guide. There is nothing to fear in this great unknown, only wonder. We are poised at the boundary of our sight, a sphere of observation, 46.5 billion light years, in radius in every direction around us. We have journeyed through the familiar and into the profoundly ancient. But what is it that we are actually looking at here at this ultimate edge? What forms this horizon? It is not a sudden blackness, not an empty curtain falling on the cosmic stage. Instead, in every direction we look, the sky is filled with a faint, pervasive, and almost perfectly uniform glow. If our eyes could see microwaves, the entire heavens would appear to be softly lit, like the inside of a frosted light bulb. This is the cosmic microwave background, the CMB. It is the most ancient light in the universe, a fossil from a time when the entire cosmos was a hot, dense, and glowing fog. It is the afterglow of creation. Let us drift into the story this light tells. For the first 380,000 years after the Big Bang, the universe was a profoundly different place. It was not a place of stars and galaxies, but a roiling, opaque soup of fundamental particles, protons, neutrons, and electrons, bathed in an intense, brilliant light. This soup is known as a plasma. In this state, the universe was so hot and dense that electrons could not settle down with protons to form stable atoms. They were free, and they were everywhere. Photons of light, the very particles we see with, could not travel far in this environment. They would be emitted, travel a tiny fraction of a millimeter, and then immediately collide with a free electron, being scattered in a random direction. It was like trying to see through the thickest fog imaginable, a fog that filled the entirety of space. Light was trapped, endlessly ricocheting within this primordial plasma. But the universe was expanding, and as it expanded, it cooled. Slowly, patiently, the temperature dropped. And when it reached about 3,000 degrees Celsius, roughly the temperature of the surface of a cool red star, a magical transition occurred. It was now cool enough for the free electrons to be captured by the protons, forming the first stable neutral atoms of hydrogen and helium. This event is called recombination. Suddenly the fog cleared. The particles of light were no longer being endlessly scattered. For the first time, they were free to travel in straight lines across the cosmos. The universe became transparent. The cosmic microwave background is the light from that very moment of clearing. It is a snapshot of the universe as it was at the instant it became see-through. Every photon in that ancient light has been traveling unimpeded ever since, journeying for 13.8 billion years across the expanding fabric of space-time to finally reach us, here, now. As this light has traveled, the universe has continued to expand, stretching by a factor of more than 1,000. And just as the sound of a siren is stretched to a lower pitch as it moves away from you, the wavelength of this ancient light has been stretched by the expansion of space. What began as a brilliant, hot, yellowish-white glow, like that of a furnace, has been stretched so much that it has become the cool, invisible microwaves that we detect today with our radio telescopes. It is a faint, cosmic hum, the echo of the Big Bang, bathing our planet and everything in our universe in its gentle, ancient radiation. The most remarkable thing about this light is its uniformity. No matter where we look in the sky, from the north celestial pole to the south, the temperature of this background radiation is almost exactly the same. about 2.725 degrees above absolute zero. This tells us something profound about the early universe. It must have been an incredibly smooth and well-mixed place, with the same temperature and density everywhere. But it is not perfectly uniform. When we look with incredibly sensitive instruments, we find tiny, minuscule variations in temperature, differences of just 1 part in 100,000. The map of the CMB is a speckle canvas of slightly warmer red spots and slightly cooler blue spots. These tiny ripples are, perhaps, the most important discovery in all of cosmology. They are the seeds of everything. The slightly warmer, denser regions had slightly more gravity. Over hundreds of millions and billions of years, that extra gravity pulled in more and more matter from the surrounding space. These were the seeds from which the first stars would sprout, the gravitational wells where the first galaxies would form. The slightly cooler, less dense regions, in turn, gave up their matter and grew into the vast cosmic voids we see today. When we look at the CMB, we are not just seeing old light. We are seeing the blueprint for the entire cosmic web, the ghostly outline of all the structure that would ever come to be. It is the universe's first photograph, and in its faint, gentle modeling, our own existence was written. So, this is the wall that defines the edge of our vision, a wall of light, a glowing surface of last scattering, beyond which the universe was an opaque fog. We can't see past it with light. But this does not mean space ends there. The universe almost certainly continues. So now, with our feet firmly planted in the understanding of this observable boundary, we can finally take that gentle, speculative leap. What lies beyond the glow? The first, and in many ways the most straightforward possibility, is simply this: more universe, more of the same. The idea that we do not occupy a special, central, or privileged position in the cosmos is a cornerstone of modern science. It is called the cosmological principle. It suggests that on the grandest scales, the universe is much the same everywhere. If this is true, then our observable universe, this immense sphere of 2 trillion galaxies, is not unique. It is just our local patch, the region of the cosmos that is currently visible to us. Imagine you are on a small boat in the middle of a vast ocean on a perfectly clear day. You can see the water and the sky out to a certain distance in every direction. This circle of visibility is your horizon. But you have no reason to believe the ocean ends at your horizon. You know, with confidence that if you were to sail for a day, you would find yourself in a new spot, with a new horizon around you, and what you would see would still be more ocean. What was previously on your horizon would now be closer, and new, previously unseen parts of the ocean would appear on your new horizon. The universe could be just like that. Our cosmic horizon is not a physical edge, it is an informational one. An observer in a galaxy that we see on the very edge of our sky would, from their perspective, be at the center of their own observable universe. They would look out and see a sphere of galaxies 93 billion light-years across, just as we do. And on the edge of their sky, in one direction, would be our own Milky Way, its light having traveled for 13.8 billion years to reach them, appearing as a faint, primitive smudge. There is nothing special about our location. The universe in this view just keeps going. Beyond our horizon lies another patch of universe, just as vast as ours, filled with more galaxies, more clusters, more filaments, and more voids. And beyond that patch, another, and another, on and on and on. This leads us to a truly mind-altering consideration. If the universe does, in fact, go on forever, if it is infinite, then we must confront the consequences of that infinity. A finite number of particle types, protons, neutrons, electrons, can only be arranged in a finite number of ways within a given volume of space. Let's think about our observable universe. It's a vast volume, but it is finite. The number of ways that all the particles within it could be arranged is staggeringly large, but it is not infinite. Now, if you have an infinite universe, an infinite amount of space, but only a finite number of possible arrangements for a patch of space the size of ours. Then, by the simple laws of probability, those arrangements must eventually repeat. Let that thought settle gently. If you travel far enough in any one direction in a truly infinite universe, you would eventually come across another region of space that is, for all intents and purposes, identical to our own. It's not a mystical idea, but a statistical one. It is the same principle as shuffling a deck of cards. There are a huge number of possible shuffles, but it is a finite number. If you shuffled the deck an infinite number of times, the exact same order of cards would have to appear again and again. So, somewhere out there, far beyond our cosmic horizon, in a patch of universe we can never see, another galaxy identical to the Milky Way is spinning in the darkness. Within it is a star identical to our sun. Circling that star is a planet identical to Earth. And on that planet, in a room identical to yours, a person who is an exact atom-for-atom copy of you is living out a life that is indistinguishable from your own, right up to this very moment. And if the universe is truly infinite, it doesn't just happen once. It happens an infinite number of times. An endless sea of cosmic doppelgangers, each believing they are unique, each living at the center of their own observable universe. And the variations would also exist. There would be universes where every detail is the same, except you chose to do one small thing differently this morning. There would be a universe where a historical event on your Earth unfolded in a slightly different way, leading to a world subtly changed. And there would be worlds where the changes are dramatic. This is the ultimate expression of the idea that we are not special. Our entire existence, every choice we've ever made, every historical event, every triumph and tragedy, could be just one of an infinite number of variations playing out across an endless cosmic canvas. This is not a parallel universe in another dimension, but right here, in our own universe, just so far away we can never reach it. It's a thought so vast it can make one feel both infinitesimally small and, strangely, infinitely connected. But infinity is not the only option. The universe could be finite, yet still have no edge. This sounds like a contradiction, but it can be understood through a simple analogy in a lower dimension. Imagine you were a two-dimensional creature living on the surface of a perfect sphere, like a balloon. Your entire universe is this 2D surface. You can walk in any direction you choose. The surface is clearly finite. It has a specific measurable surface area. But you will never, ever find an edge. If you walk in a straight line, you will not fall off. You will simply continue until you have circumnavigated your entire world and arrive back where you started, from the opposite direction. Your universe is finite, but unbounded. Our three-dimensional universe could be like that. It could be curved back on itself in a fourth spatial dimension, just as the 2D surface of the balloon is curved in a third dimension. If this were the case, space would be finite. It would contain a finite number of galaxies and a finite amount of energy. But it would still have no edge, no center, and no boundary. If you could travel in a perfectly straight line for an unimaginably long time, you would eventually return to your starting point. The light from a distant galaxy could, in principle, travel all the way around the universe and be seen by us from the opposite direction, appearing as another, much fainter and older galaxy. Cosmologists describe the overall geometry of the universe in three possible ways. It can be closed, like the surface of a sphere. In such a universe, gravity is strong enough to eventually halt the expansion and cause the universe to collapse back in on itself in a big crunch. It can be open, shaped like a saddle, where it expands forever. And it can be flat, the perfect balance between the two, where it also expands forever. But the rate of expansion gradually slows, approaching zero. A closed universe is finite. An open and a flat universe are, in the simplest models, infinite. All of our best measurements to date, especially from the cosmic microwave background, suggest that our universe is astonishingly, remarkably flat. It seems to obey the rules of standard Euclidean geometry that we all learn in school. Parallel lines stay parallel. The angles of a triangle add up to 180 degrees. This flatness points towards the idea of an infinite universe. But there is a subtlety. It is possible that the universe is, in fact, curved, but on a scale so gigantic that our entire observable universe is just a tiny patch of it. In this case, it would appear flat to us for the same reason that the surface of the Earth appears flat to a person standing in a field. The curvature is real, but you can only detect it from a great distance, or by making incredibly precise measurements over a huge area. Our universe could be a colossal, finite sphere, so large that we cannot perceive its curvature from our limited viewpoint. So, we are left with these two grand competing possibilities for the reality that lies just beyond our sight. Is it an infinite expanse, a boundless ocean of space and time, where every possibility is realized somewhere, an endless tapestry of repeating patterns? Or is it a vast but ultimately finite and self-contained object, a cosmic jewel that curves back on itself, complete and whole, but so large that its true shape remains hidden from us? Both possibilities are staggering in their own right. One offers an eternity of repetition, the other a universe of ultimate, if incomprehensible, unity. Both tell us that what we can see is not the whole story. The cosmic ocean, whether it is endless or loops back on itself, is far, far larger than the small circle of water visible from our boat. The mystery remains, inviting us to wonder, to speculate, and to dream. And this is only the beginning of the possibilities, for there are other ideas born from even deeper, stranger theories that suggest what lies beyond is not more of the same, but something else entirely, something fundamentally different. We stand at the edge of our perception, looking out at the faint, ancient glow of the cosmic microwave background. Beyond this veil of light, we have imagined a universe that continues, either infinitely or as a vast, finite loop. These are majestic possibilities, painting a picture of a cosmos grander than we can ever fully grasp. Yet, some of our deepest theories about the origin of our own universe hint at something else. They suggest that what lies beyond our horizon is not simply more space, but more creation. They whisper that our Big Bang may not have been a singular, unique event, but merely one instance of a process that is eternal and ongoing. To understand this, we must travel back in our minds even further than the CMB, to the very first fraction of a second of our universe's existence. The moment after the Big Bang was a time of unimaginable energy and density, and in this crucible of creation, physicists believe the universe underwent a period of truly astonishing expansion. This is the theory of cosmic inflation. It proposes that in the first tiny sliver of a second, a period so short it makes a blink of an eye seem like an eternity, the fabric of space itself expanded at an explosive, exponential rate. It grew faster than the speed of light, swelling from a size smaller than a single proton to something larger than a modern galaxy, all in an instant. It is difficult to conceptualize this. It is not like an explosion in space, but an explosion of space. The very grid lines of reality were being stretched apart at a furious pace. This inflationary period was brief, but it was formative. It took the nascent universe, which may have been a chaotic, wrinkled, and lumpy thing, and stretched it out so vast and so fast that it became incredibly smooth and flat. It's like taking a small, crumpled piece of foil and stretching it out into a huge, flat sheet. All the original wrinkles and creases are smoothed away into near perfection. This is why our universe today appears so flat, and why the cosmic microwave background is so astonishingly uniform in temperature from one side of the sky to the other. Inflation provides a beautiful and elegant explanation for the universe we see. But here is where the idea takes a turn into the truly profound. According to the physicists who first developed the theory, inflation, once it begins, is a very difficult process to stop everywhere at once. It is a state of high energy, a false vacuum that is powerful and self-perpetuating. The theory of eternal inflation suggests that while this period of hyper-expansion ended for our patch of the cosmos, allowing matter and energy to condense and form the universe we know, it may not have stopped elsewhere. Imagine the grander reality, the metaverse, as a vast ocean of this inflationary energy, eternally expanding and churning. It is a state of perpetual, furious creation. Within this ocean, from time to time, a small region can, by chance, decay out of this high-energy state into a lower-energy state, much like a bubble forming in a pot of boiling water. When this happens, the inflationary stretching in that local region comes to a halt. The tremendous energy that was driving the inflation is released, flooding that new bubble with matter and radiation, creating the hot, dense conditions of a Big Bang. In this breathtaking picture, our entire universe, not just the part we can see, but everything, even the parts beyond our horizon, is just one of these bubbles. It is a single calm pond that formed in a vast, eternally raging cosmic storm. And if it happened here, it must have happened elsewhere. The inflationary ocean is constantly, eternally giving birth to new bubble universes, each one experiencing its own Big Bang, each one expanding and evolving in isolation. This is the origin of the concept of the multiverse. What lies beyond our universe in this view is not just empty space, but a sea of other universes, a cosmic foam of countless worlds. Each bubble is a self-contained cosmos, and because the inflationary space between them is expanding faster than the speed of light, they are forever separated. They are causally disconnected. We can never send a message to another bubble universe, nor can we ever receive one. We can never visit. They are the ultimate undiscovered countries, existing in the same grand reality, but forever beyond each other's horizons. This idea, as speculative as it is, offers a potential solution to one of the deepest mysteries in physics, the fine-tuning problem. As scientists have measured the fundamental constants of our universe, the strength of gravity, the mass of an electron, the energy of empty space, they have found that many of them seem to be exquisitely precariously balanced to allow for the existence of complexity. If the force of gravity were just a tiny bit stronger, the universe would have collapsed back on itself moments after the Big Bang. If it were a tiny bit weaker, stars and galaxies would never have been able to form. If the nuclear force that holds atoms together were slightly different, there would be no carbon, and therefore no possibility of life as we know it. Our universe appears to be walking on a razor's edge, a cosmic acrobat on a tightrope of improbable constants. Why should this be so? It can feel like a miracle, as if the universe were specifically designed for us. But the multiverse offers another perspective. What if each bubble universe that forms in the eternal inflationary sea is born with its own unique set of physical laws? What if the fundamental constants are not fixed, but are randomly set each time a new bubble forms? If this were the case, then the vast majority of these universes would be sterile and uninhabitable. Imagine a bubble where gravity is 10 times stronger. Stars would form, burn their fuel in an instant, and collapse into black holes. No time for planets, no time for life. Imagine a bubble where the electromagnetic force is weaker. Atoms would not hold together. There would be no chemistry, no structure, just a thin, formless soup of particles. The cosmic foam would be filled with countless failed universes, silent, dark, or fleeting, each one a testament to a set of laws that did not permit complexity to arise. And then, there is our universe. We find ourselves living in a cosmos where the laws happen to be just right for stars to form and burn for billions of years, for planets to coalesce in stable orbits, and for the elements of life like carbon and oxygen to be forged and distributed. Is this a miracle? The multiverse suggests it is not a miracle, but a matter of statistics. It is the anthropic principle. we find ourselves in a universe that can support our existence simply because we could not exist in the others to ask the question. It's like finding a single, perfectly green, lush oasis in the middle of an unimaginably vast desert. If you were born in that oasis, never having seen the surrounding desert, you might think it was a miracle. You might wonder why this one spot was so perfectly suited for life. But if you could pull back and see the entire desert, and you knew that the desert stretched on for billions of miles, and that oases formed randomly, your perspective would change. It would no longer be a miracle to find yourself in an oasis. It would be an inevitability. You are there because it is one of the only places you could be. The multiverse proposes that our universe is just such an oasis. We are the beneficiaries of a cosmic lottery. Our laws of physics are not special, they are simply lucky. And this idea transforms the Big Bang from a singular moment of creation at the beginning of all time into a natural, repeatable process of cosmic birth. The multiverse is a celestial garden, eternally blooming with new universes, and we are just one flower in that garden. Let this concept settle in your mind. Imagine this cosmic foam, countless bubbles, each one a universe, popping into existence from the churning sea of inflation. Some are vast and long-lived like ours. Others might be tiny, collapsing back into nothingness in a fraction of a second. Some might be filled with light and stars. Others might be forever dark. Some might be governed by forces we can't even imagine, filled with exotic particles and strange geometries. The sheer variety and scale are beyond our ability to truly picture. This vision can feel both humbling and liberating. It can make our entire cosmos, with its trillions of galaxies, feel small, just one bubble among countless others. But it can also make our existence feel less precarious, less like a fragile one-off accident, and more like a natural expression of the universe's infinite potential for creation. We are not a fluke, we are a consequence of a reality that is so vast and so fecund that it tries out every possibility. There is a quiet beauty in this idea. It suggests a universe, or a metaverse, that is not static or finished, but is dynamic and alive, constantly giving birth to new realms of possibility. It connects us not just to the history of our own universe, but to a potential cosmic genealogy that stretches across countless worlds we will never see. We are a part of a family of universes, related by our common origin in the eternal, creative fire of inflation. So, when we ask what lies beyond the edge of our sight, one possible answer is not just more space, but more worlds, an endless ocean of them, each one a complete story in itself, with its own beginning, its own evolution, and its own destiny. They are our silent neighbors in the grandest sense, forever close in theory, but forever distant in practice. The multiverse is a lonely concept in that we can never reach out and touch these other worlds, but it is also a unifying one, suggesting that the creative spark that ignited our cosmos was not a singular event, but is the eternal heartbeat of reality itself. And yet, even this breathtaking vista of a foam of universes is not the only strange possibility that modern physics considers. There are other theories, equally as profound, that suggest other realities may not be separated from us by unimaginable distances, but by something else entirely. They hint that another universe could be closer to you right now than the walls of your own room, separated from us not by space, but by a direction you can never point to, a dimension you can never perceive. This path leads us to the strange and elegant world of string theory, and the idea that our universe is merely a shadow on a cavern wall, with the true reality existing just out of sight. We have imagined the grandest of possibilities, that our universe is just one bubble in an eternal, frothing foam of other worlds, each born from the same creative fire, but forever separated by unimaginable gulfs of inflating space. It is a vision of cosmic loneliness and yet profound connection, a family of universes that can never meet. But there is another school of thought, another whisper from the deepest corners of theoretical physics that suggests something else entirely. It proposes that what lies beyond our universe is not far away at all. In fact, it might be closer to you than your own hand. It may be separated from us not by distance, but by a direction that is impossible for us to perceive. To explore this, we must gently delve into one of the most elegant and ambitious ideas ever conceived: string theory. For decades, physicists have dreamed of a theory of everything. This would be a single, unified mathematical framework that could describe all the fundamental forces of nature, from the gravity that holds planets in orbit, to the strong nuclear force that binds atoms together, to the electromagnetism that creates light, all within one beautiful equation. String theory is perhaps our most promising candidate for such a theory. It begins with a simple, yet revolutionary premise. The fundamental constituents of our universe are not point-like particles, as we have long imagined. They are not tiny, indivisible dots. Instead, at the very deepest level of reality, everything is made of incredibly tiny, one-dimensional, vibrating loops of energy. They are called strings. Imagine a single string on a cello or a violin. By itself, it is just a string, but when you pluck it, it vibrates and creates a musical note. If you change the tension or the length of the string, or how you pluck it, it vibrates in a different way and creates a different note. String theory proposes that the universe works in a similar way. There is only one fundamental ingredient, the string, but each string can vibrate in countless different ways, an endless number of different notes. Each unique vibrational pattern corresponds to a different fundamental particle. One vibration appears to us as an electron. Another vibration appears as a photon, the particle of light. Yet another appears as a quark, the particle that makes up protons and neutrons. All the rich diversity of particles that we see in the universe is, in this view, just the different notes of a single grand cosmic symphony being played on these tiny fundamental strings. It is a picture of profound elegance. The entire universe, with all its complexity and variety, arises from the simple music of these vibrating strings. But this beautiful theory comes with a startling condition. For the mathematics of string theory to work, for the equations to be consistent and to describe the world we see, the universe must have more dimensions than the ones we know. We are familiar with 3 dimensions of space: length, width, and height, and 1 dimension of time. String theory, in its various forms, requires a total of 10 or 11 dimensions to exist. So the question immediately arises: if these other 6 or 7 dimensions are real, where are they? The traditional answer is that these extra dimensions are compactified. This means they are curled up on themselves on a scale so unimaginably small that we could never perceive them. Imagine looking at a long, thin power line from a great distance. To you, it appears as a simple one-dimensional line. It only has length. But if you were a tiny ant walking on that power line, you would experience it very differently. For the ant, the power line has a second dimension. It can walk along the length of the wire, but it can also walk around its circumference. This second dimension is real, but because it is so small and curled up, it is invisible from a distance. String theory suggests that our universe is like that. At every single point in the space around you, there exist 6 other spatial directions, but they are curled up into a tiny, intricate shape, a complex geometry far smaller than a single atom. We can move freely in the 3 large dimensions we know, but we cannot enter these curled up dimensions because we are simply too large. They are a hidden, microscopic aspect of space-time itself, a secret geometry woven into the very fabric of reality. For a long time, this was the prevailing view, but a more modern version of string theory, known as M-theory, allows for a different, even more dramatic possibility. It suggests that not all of the extra dimensions have to be small. Some of them could be large. In this scenario, our entire three-dimensional universe might be what is known as a brane, which is short for membrane. Imagine our cosmos as a vast three-dimensional sheet, or membrane, existing within a larger, higher dimensional space, a space that is often called the bulk. Let us return to a simpler analogy. Picture a single thin slice of bread in a whole loaf. For a creature that can only live on the surface of that one slice, its entire universe is that slice. It can move left and right, forward and back, but it has no concept of up or down into the other slices of the loaf. Our universe could be just like that slice of bread. We are three-dimensional beings, and all the particles and forces that make up our world are confined to this 3D brane. A photon of light, once created, can travel for billions of years across our universe, but it cannot leave our brain and travel out into the higher dimensional bulk. The same is true for the electrons and quarks that make up our bodies. We are, in a very real sense, stuck to our membrane of reality. If this is true, then what lies beyond our universe takes on an entirely new meaning. What lies beyond is not necessarily more of our kind of space, far away. It could be another universe, another brane, floating parallel to our own in the higher dimensional bulk. There could be another entire cosmos, with its own stars, its own galaxies, and perhaps its own forms of life, existing less than a millimeter away from you right now, but completely invisible and inaccessible to us because it is on a different sheet of reality in a direction we can't point to. The space between branes is not our kind of space. It is a dimension of a different order. This is a breathtaking and almost ghostly concept, an entire parallel universe, hovering just out of reach. Could we ever know if it was there? For the most part, the answer would be no. Since light is stuck to our brane, we could never see another brane. Since our matter is stuck here, we could never travel there. The two universes would be like two panes of glass, almost touching, but the inhabitants of each one are completely blind to the other. They would slide past each other like silent ghosts in the grand, higher dimensional cathedral of the bulk. But there may be one exception, one force that is not stuck to the branes. That force is gravity. In Einstein's theory of general relativity, gravity is not a force that is transmitted by particles in the same way as electromagnetism. Gravity is a feature of space-time itself. It is the curvature of the fabric of reality. If the bulk represents the true, higher dimensional space-time, then gravity might be free to travel across it, from one brane to another. This idea provides a fascinating and elegant potential solution to another deep cosmic mystery. Why is gravity so incredibly weak compared to the other forces of nature? The electromagnetic force between two protons is about 1 trillion times stronger than the gravitational force between them. It is a colossal difference. But if gravity is the only force that can leak out into the higher dimensional bulk, this might explain why. Its strength in our universe would be diluted because its influence is spreading out across all the extra dimensions. It's like the ripples from a stone dropped in a pond. The ripples are strongest near the center, but as they spread out, their energy is distributed over a larger and larger circumference, and they become weaker. Gravity's weakness could be the first tantalizing clue that these extra dimensions are real. And if gravity can travel between branes, then we might just be able to detect the presence of a parallel universe next door. We would not see its light, but we could feel its gravity. Some physicists have speculated that the mysterious substance known as dark matter could be evidence of this. Dark matter is a form of matter that we cannot see, but we know it exists because we can detect its gravitational pull, holding galaxies and clusters of galaxies together. It makes up about 85% of all the matter in the universe, but we have no idea what it is. What if dark matter is not made of some exotic, unknown particle on our brane, but is simply the gravitational shadow of ordinary matter, stars, gas, and planets, existing on a nearby parallel brane? We feel its gravity reaching across the tiny gap in the bulk, but its light remains forever trapped on its own sheet of reality. This model also offers a new, dramatic story for the origin of our universe. The Big Bang in this picture might not have been the beginning of everything, but simply the result of a cataclysmic event in the bulk. Imagine two of these parallel brain universes, drifting silently through the higher dimensional space, and then they collide. This collision would release a tremendous, unimaginable amount of energy, and that energy would pour into the brains, creating a hot, dense fireball of particles and radiation on each one. This event, this brain collision, would be what we experience as our Big Bang. This is known as the ekpyrotic model of the universe. It suggests our cosmos was born from a cosmic clap of two worlds touching in a higher dimension, and it could happen again. The brains could drift apart, cool down, and then, billions of years later, collide once more, creating a cyclical universe of repeated births and deaths. So here we have another vision of what lies beyond, a layered reality, a cosmic millefeuille of universes separated by whispers of higher dimensional space. In this view, the beyond is not a question of distance, but of dimension. The universe beyond is not a place we would reach by traveling for eons in a straight line, but by somehow taking a step in a direction that does not exist in our experience. It is a universe that is both profoundly separate from and intimately connected to our own. We are isolated on our membrane, yet we may be subtly touched by the gravitational breath of our neighbors. It is a humbling thought to imagine our entire, vast cosmos as just one page in a much larger book, with stories being written on the pages just before and just after ours. Stories we can never read, but whose weight we might just be able to feel. Each of these possibilities, the infinite tapestry, the finite loop, the cosmic foam, the layered brains, is a testament to the power of human imagination to grapple with the immense. Each one is a beautiful, self-consistent story, born from the clues the universe has given us. But there is one final possibility we must consider, one that is perhaps the most unsettling and the most philosophical of all. It asks us to question not just the nature of the space beyond our universe, but the nature of our universe itself. What if the universe is not a physical place at all? What if what lies beyond is not another universe, but another level of reality entirely? This is the path that leads us to question whether we are living in a dream, a simulation created by some intelligence far beyond our own. We have stood at the edge of our cosmic sight and imagined a universe that continues on forever, an infinite tapestry where our own lives are repeated in countless variations. We have pictured a cosmos that is finite yet unbounded, a great self-contained sphere of space-time. We have dreamed of a multiverse, a bubbling foam of separate realities born from an eternal sea of creation. We have even contemplated a universe of layered brains, parallel worlds hovering just a whisper away from us in a higher dimension. In all of these visions, as strange and grand as they are, we have held on to one fundamental assumption, that our universe is a physical, natural place, that it arose from the laws of physics and exists as a thing of matter, energy, space, and time. But there is one final door of possibility to open, and to do so, we must be willing to question that last, most basic assumption. What if our reality, with all its intricate laws and stunning beauty, is not a natural phenomenon at all? What if the universe is an artifact? This is the path that leads us to the simulation hypothesis, an idea that is both deeply philosophical and strangely logical. It asks us to consider, just for a moment, that we might be living inside a vast, sophisticated computer simulation. Let this not be an alarming thought, but a quiet, curious one. Think of it as the ultimate thought experiment. The argument for it is surprisingly straightforward. It begins by assuming that consciousness, our self-awareness, our ability to think and feel, is something that can, in principle, be replicated in a computer. If a brain is a complex biological machine, then a sufficiently powerful computer should be able to simulate the functions of that brain, and thus, the consciousness it produces. The argument then proceeds in 3 gentle steps. First, it seems likely that a civilization could become technologically advanced enough to build computers of such immense power that they could simulate an entire universe, or at least a significant portion of it, complete with conscious beings living inside. Think of the video games and virtual realities we can create today, and then imagine that technology advancing for thousands or millions of years. It is not a huge leap to suggest that creating such ancestor simulations would eventually become possible. Second, an advanced civilization that can run such simulations would likely run many of them, perhaps for scientific research, to study how universes evolve, perhaps for entertainment, or for art, or perhaps for reasons we cannot even fathom. But it is probable that they would not just run one simulation. They would run thousands, millions, or even billions of them. This leads to the third and final step, which is the heart of the hypothesis. If this is true, then the number of simulated realities containing simulated conscious beings would vastly astronomically outnumber the one single base reality where the simulators live. For every one real world, there could be billions of simulated worlds. If this is the case, and you are a conscious being, what is more probable? That you are one of the inhabitants of the single, original base reality? Or that you are one of the countless trillions of inhabitants of one of the many simulations? Statistically, the odds would be overwhelming that you are living inside a simulation. We are, in this view, characters in a story being written in code. The laws of physics that we have discovered with such care, from Newton's gravity to Einstein's relativity to the strange rules of quantum mechanics, might not be fundamental truths of nature. They could be the lines of code, the algorithms that define the operating system of our simulated reality. They are the rules of the game, elegant and consistent, because they were programmed that way. What then would the edge of the universe mean in such a reality? It could be something far more mundane and practical than a cosmic light horizon. It could simply be a computational boundary. Running a simulation of an entire universe would require an almost unimaginable amount of computing power. To save resources, the simulators might only render the parts of the universe that are actually being observed by the conscious beings within it. Why waste processing power calculating the state of a galaxy that no one will ever see? In this light, the edge of the observable universe might be the literal edge of the rendered map. The cosmic microwave background, that beautiful ancient afterglow of the Big Bang, might not be a real photon wall from the distant past. It could be a skybox, a term from video game design for a detailed static background image that creates the illusion of a much larger world. It is the beautifully painted backdrop at the edge of the stage, designed to look like a real horizon. Beyond it, there would be nothing. Not empty space, not other universes, but simply null, an unallocated part of the cosmic hard drive. The simulation simply stops there, because for its inhabitants, it doesn't need to go any further. Could we ever find proof? Could a simulated being ever discover the nature of its prison or its playground? Perhaps. Some have speculated that we might look for glitches in the matrix, small inconsistencies in the laws of physics that betray their artificial nature. So far, our universe has been found to be remarkably consistent, but perhaps we haven't looked closely enough. Others have suggested looking for signs of the underlying computational grid. Physicists have long theorized about a smallest possible unit of length, called the Planck length, a fundamental resolution below which the concept of space itself may break down. Could this be the pixel size of our universe, the ultimate grid on which our reality is rendered? If we could ever probe to that scale, we might find that space is not smooth and continuous, but discrete, like the pixels on a screen. Or perhaps the evidence would come from the laws themselves. If you were programming a universe, you might take computational shortcuts. You might simplify certain complex calculations. Do any of our physical laws seem strangely convenient or simple? The speed of light, for instance, being a universal constant, is a very useful rule for a simulation, as it provides a clear limit on how fast information can travel, preventing all sorts of computational paradoxes. It is all, of course, wild speculation. The universe, to the best of our ability to measure it, appears perfectly natural and real. But the simulation hypothesis remains a quiet, persistent whisper. A philosophical puzzle that reminds us to question even our most fundamental assumptions about what is real. And so, our long journey of the mind comes to its end. We have traveled from our quiet, familiar room to the furthest reaches of space and time. We have stood at the edge of our sight and peered into the possibilities that lie beyond. We have contemplated an endless cosmos, a repeating tapestry of infinite worlds. We have imagined a finite universe, a single, perfect cosmic jewel curved back upon itself. We have drifted through the cosmic foam of a multiverse, a garden of countless bubble universes, each with its own unique life. We have glimpsed the ghostly possibility of layered parallel worlds existing just a breath away in a higher dimension. And finally, we have questioned the very reality of the canvas itself, entertaining the thought that our entire existence might be a beautiful and profound simulation. Which of these is the truth? We do not know, and it is possible that we may never know. The edge of the universe is also the edge of our knowledge, a boundary that may be forever impassable. But perhaps the purpose of this journey is not to arrive at a final answer. Perhaps the purpose is the journey itself. The act of looking up at the sky and asking "what if" is one of a profound humility. It is an acknowledgement that the reality we experience is just a tiny sliver of what is. It connects us to every human who has ever looked at the stars and felt a sense of awe and wonder. It is time to come home now. Let us gently pull our awareness back from these vast and dizzying concepts. Back from the edge of the simulation, back from the higher dimensions, back from the sea of other universes. We drift back across the cosmic web, its filaments of light guiding us home. We see our own supercluster, our own local group, and then the familiar, comforting swirl of our own Milky Way galaxy. We find the quiet, outer spiral arm where our sun resides, that gentle, steady star. We see the family of planets circling it, and among them, the small, bright blue marble of Earth. We descend through the atmosphere, through the clouds, back down to the continent, the country, the city, and the very room where you are now resting. Feel the gentle weight of your body, the softness of the surface beneath you, the quiet rhythm of your own breath. You are back. You are here. You are safe. The great mystery of the cosmos is still out there, unfolding in its silent, majestic way. But you are here, in this moment of peace. The edge of the universe is not just a place far away in space. It is a concept within us. It is the boundary of our own imagination and understanding. And by gently pushing against that boundary, by allowing ourselves to wonder about the immense and the unknown, we connect with something essential about our place in the cosmos. We are small, yes, but we are also the part of the universe that is able to look back on itself and be stunned into silence by its own beauty. I hope this journey has been a peaceful one for you. I hope it has brought you not confusion, but a quiet sense of wonder. Drifting off to sleep with a mind full of starlight and possibility is a beautiful way to end the day. Thank you for joining me on this voyage. May your rest be deep and untroubled, and may your dreams be as vast and as beautiful as the universe itself. Sleep well.